we're trying to put together ecological, what's basically more a better experience in spite of this.
How did you come up with the name Education in the Anthropocene?
Well, actually, it was originally Education for the Anthropocene, then became Economics for the Anthropocene. And the basic idea is that now that humans are the, people know here what the Anthropocene is? So the Anthropocene, the idea, they're actually considering declaring a new geological age. So right now we're in the Holocene. So for the past 11,000 years, we've had this freakishly stable climate. And I don't believe it's coincidentally that civilization, agriculture and civilization arose about 11,000 years ago. So you need a stable climate to have agriculture. And in the past, the biggest geological forces were tectonic plate shifts, volcanic activity, all sorts of things define the geological age. But now the biggest impact on the scale of geological forces on the planet is humans. So Anthropocene, we're the ones who are changing everything. And it's quite possible this will become, it will be declared a new geological age. And so there's new challenges in a situation like this, where our economic activities, so we have economics with Anthropocene, where our economic activities affect the entire world in a profound way, not just humans, but other species, climate, ocean acidity, so we really think that kind of the view is that over time, there's an amazing phase transition in our economic system at the beginning of the Holocene, where we went from hunter-gathering to agriculture. And that's as big a change we've ever had. And so a change in our natural environment requires adaptation and a change in our economic system. And so now we have to prepare for the next major change. So that's essentially why we came up with the economics for the Anthropocene. And it's also, one of the goals here is that economics is no longer, our economic activities are no longer divorced from physical reality. That our economic activities really have a profound impact on ecosystems and even physical systems. And yet, the discipline of economics is almost completely divorced from the natural sciences and other disciplines. And that there's a whole bunch of disciplines, actually, that it was okay, it was okay for economics not to focus on these huge ecological and physical events when they weren't happening and we had no impact on it. But now that's changed. But there's quite a few disciplines are disconnected from the natural sciences. And the guy who came up with this economics for the Anthropocene is Peter Brown at McGill, and he calls them orphan disciplines. So they're disciplines that are not interconnected with the web of science, you might say. And we'll be talking a lot about that in this class, is how economics, conventional economics, is completely disconnected from the physical sciences and physical, natural, and human sciences, or humanities, and ecological economics tries to bridge that gap. So I think that's the basic idea behind it, and it'll be a recurring theme. So to begin with, this is just all that stuff. So our seminar. So the idea, it's a seminar. I don't want to be sitting here lecturing to you, but with 26 students, there's going to have to be a little workaround. So I'll explain all that. And so how many people actually had, so this is the thing, also first class, even this is too big, I think. So one of the things I'm going to play around with is I want to get to know who all you are, and so you guys get to know each other. I think 17 is too big, but what I thought we'd just do today is, so everybody's got to contribute today to the discussion. And the first time you contribute, you just tell us about, what you're studying here, why you're taking this class, what you plan to do, why you're taking, your major or whatever you're studying, this class is part of it, and what you plan to do with all that in the future, basically. Tell us a little bit about yourselves. And everybody's got to contribute at least once before somebody else contributes. So, and if you're not responding, nobody responds to a prompt or something, then I'll just point and ask. Because I want to get everybody engaged, and I want to get used to it from the beginning. So I just figured I'd try that. And why is this thing screwed up? So to start out with, what we're looking at, and I want this to be mostly discussion. So we're studying economics here, and ecological economics, and actually, in a way that's not quite true. Ecological economics is not just economics. But I do want to, I'm an economist, I want to ground this in economics. And this is, I actually started out a lot of my classes with just this question. So, Dave was in another class of mine yesterday, and but if somebody asks you, what is economics? What are you studying? When, or why are you studying economics? What is it? How would you define it? How would you guys say, what is economics?
The way resources move around.
And you might as well just introduce yourself.
I'm Deandra. I'm a CDAE MS student. I'm from New Hampshire, and I'm not sure what I'm going to be doing with this degree, so I'm really, trying to find out what I'm interested in, and this is definitely something that I like a lot. And yeah, that's really basic, but I would say the way maybe resources move around within a system.
And I should just add to what you said is that when I was doing my master's degree, one thing I was sure of is I wouldn't be an economist.
I'm not going to be a teacher.
So the way resources move around, but that's a pretty broad definition. Can you narrow that at all? Because before humans existed, resources moved all around. Like the salmon used to transport absurd amounts of resources way upstream from the ocean.
In a human system?
In a human system. Any other elaborations on that definition, or?
What was scarcity? That's coming to play at some point. Brian O'Connor, CDAE MS student, worked in a corporate environment for 2 years and want to get out of it.
All right, so scarcity. So elaborate on that definition using scarcity.
It is the redistribution or distribution of resources that are limited to try to optimize.
Try to optimize what? Utility is the typical. Okay, so that's actually a more complete definition. But again, so what's scarce? What's a scarce resource?
Anything that anyone needs.
I need oxygen. Is that scarce? So introduce yourself too.
My name's Alex Helling, originally from South Dakota. I am an MS student in the CDAE program. I have a background in farming and environmental science, so I'm really interested in food systems and the interplay of economics. So that drew me to ecological economics. So I guess just from my basic knowledge of the definition of scarcity is that it is whenever somebody needs something in an economic sense, it will be created to fill that need of scarcity. So whenever a human needs something, it can be defined as scarcity. So because, in the broadest sense, because somebody will then need to fill that need.
Well, so again, it's like I need oxygen. We all need oxygen, and but is it scarce?
No. So maybe a good that's produced by humans.
Finite?
So oil
Finite good.
is oil scarce?
Depends on how you look at it.
Yeah. So oil.
In what geological sense.
Yeah. So oil, because oil is not produced by humans. I mean, oil is so. So any further elaborations on scarcity?
But there's a finite amount of something. I think that the word was
Well, there's a finite amount of oxygen at any given time. I mean, there's a flow over time, or there's a finite amount of my daughter's artwork. Is it scarce? She, 35 new pieces a day, but it's still a finite amount.
It could be scarce to a person that can't breathe.
If we sealed this room airtight, oxygen would very, very rapidly become scarce. So
I think that's where. So I'm Andrew. I'm a MS student in CDAE, and I'm here because I'm interested in agroecology in the tropics. And so I think this is where time comes in, right? Is that you get to a point where you're threatening scarce resources, so that we can't continue to exist, and the world can't continue to support us. So there's a threshold that you can pass.
So one very, very important point to bring in is scarcity over time. There might be abundance now, but if we use it all up, then it becomes scarce. And Mary Jane, you should introduce yourself too.
Sorry about that. I'm Mary Jane Fox. I'm a PhD student in natural resources, and I taught ecological economics before, but I apparently don't know how to define economics, so that's a good start. And the reason I've been interested in this field, I have a master's in science and ecological economics from the University of Edinburgh, and so I've been interested in this field for 8 years or so, maybe longer than that. And it's amazing to me I'm in this class right now, because University of Vermont, this program, Josh's book, have been like fundamental to my education, so hooray.
As I point out, we're not going to use my book.
But still.
All right, so scarcity, the way economists tend to define scarcity, they tend to ignore the time component, but they say there's not enough of the resource to meet all competing needs. So oil, we use 80 million barrels a day in the world, which seems like a lot, but it's such a valuable resource, there's still not enough to meet all our, people would like to use more, and there's not enough to go around. So because there are people who would like to use it and there's not enough available, we've got to make choices. We've got to decide how that oil is going to be used. Yeah, Dave.
Dave Gammon. I am a biology professor in North Carolina on sabbatical doing the certificate program in ecological economics. So it seems to me that scarcity is a continuum, and I would guess that economists would acknowledge that some resources are much more scarce than others.
And how do we know, from an economist perspective, how do we know how scarce a resource is?
They would probably go to price. That the higher the price, the scarcer the resource.
So price is intended to measure scarcity. So just does anybody know what happened to the price of oil from, say, 1910 to 2000?
Went pretty low.
It went, so basically, the mean, it hovered around the mean, but actually was on a slight downward trend, if anything.
Right.
So what happened to the scarcity of oil from 1910 to 2000?
Economists would say that it decreased because we became so efficient at extracting new oil and distributing it that from an economic perspective, they would argue oil is less scarce than it was.
Yeah. So scarcity has two factors, which is supply and demand. So what happened to the supply for oil over that time, the geological supply?
It's fixed.
But it plunged because we used an enormous amount of it.
Okay, right.
So the geological supply plunged. What happened to the demand for oil? Skyrocketed. So what we have here is a situation where economists, you're right, would say the scarcity decreased because the price went down, yet the physical supply plunged and the market demand skyrocketed. So how is it that economists would say it became more abundant?
Well, it's easy if you're a discipline that's divorced from the natural sciences. You don't have to worry about what happened millions of years ago or what will happen 300 years from now.
So you're divorced from the natural sciences and you're divorced from time because you don't care what happens in the future. So you know, so we want to, so there's scarcity. And so economics is, you know, basically, to summarize what you said, this is a typical definition of economics: allocation of scarce resources among alternative desirable ends for this and future generations. An ecological economist would add, conventional economists would not. So we say time matters, future generations matter. So one thing about this, you know, is this thing about desirable ends. Believe it or not, this is controversial. So I just wrote a paper this summer, and I hadn't realized how controversial this was. I wrote a paper this summer in which I was trying to argue that economics has to become more conciliant with the other sciences. We can't say things that contradict what physicists and ecologists and chemists say. We have to agree with the mainstream scientists, you know, and that science moves together. And I used this definition, and one of the reviewers, who's an economist, said, has nothing to do with desirable ends. We don't care if the ends are desirable or not. And I was thinking, well, you know, what the hell is this guy talking about? And so I reviewed the stuff I'd learned, and what economists say, so, you know, how do we decide what are the desirable ends? You know, who we're going to have? A bunch of, who decides on the desirable ends? And so what economists actually say is the only person who can decide on the desirable ends, or the end, is the individual, and it's individual preferences. So we don't judge things on whether or not they're desirable. We judge things on whether or not you want them as an individual. So it's subjective preferences. You decide what's desirable for you. Society has no say. So if you want to buy heroin, that's up to you. If you want to, you know, eat huge amounts of sugary food and become obese, that's totally up to you. It's subjective preferences. So what economists, but it's still, in my view, it's still the desirable end. It's economists define the desirable end as whatever the individual wants, regardless of its objective impact on that person. So it's subjective preferences. Nobody can say what's good or bad for somebody else, but it's still, in my view, we're just saying the desirable end is, you know, whatever you want, but it's still a desirable end. And so but what economists want to do is they want to say, well, if we're talking about desirable ends, that's a normative thing. That's a value judgment, a value statement. So economists say we're not, we're a science. We're a positive science. We're not dealing with these, you know, sketchy value statements or things that are, you know, that's for the social sciences, humanities. We're a real science based on math. Well, there's no value, is it right or wrong that, the derivative of x squared is 2x? Is that right? You don't have value statements in there, and that's what they want economics to be, math-based, value-free. And if it's value-free, it can't be about desirable ends. It's got to be about objective, observable facts. And they say the objective observable fact is subjective preferences, but they're still saying that the desirable end is for people to satisfy their objective preferences. And in ecological economics, we're making the case that economics is absolutely normative. Right and wrong matter. Values matter. And it's absurd. I just think it's almost comical that the economists say that, it's not about desirable ends. It's just about competing ends. But anyway. So now another question, though. Is this a good enough definition? Are there resources that aren't scarce that matter how we allocate them? So, a scarce resource, there's not enough to go around. We compete for it. So we compete for access to oil, for example. If I burn a barrel of oil, none of you can burn it. I drive here in my car and that oil's gone, it's not available for you, we've got to compete. One of us gets it, the other one doesn't. So what are we going to do if we go beyond fossil fuels? What's our new, what do we got to focus on now if we want a sustainable economy for energy? What's going to be an energy source in a sustainable economy? So solar. Ultimately, because hydro is solar, wind is probably mostly solar, solar is the thing. So if the US uses huge amounts of solar energy, how much does that leave for India and China? It has no impact. So
the scale's gonna matter. I mean, so solar is sustainable if it's a constant amount of solar that we use per year. If it's a growing amount of solar indefinitely, that's not at all sustainable.
No, it's not all sustainable, you're absolutely right. And but we're basically, and so I totally agree, I think that endless growth of anything is impossible. And solar, we find, if we replaced all of our current fossil fuel energy use with solar, we would need to add like 1 gigawatt of solar power per day for the next 50 years. So that's like a giant nuke, that's like you probably just heard that Yankee got decommissioned. And that would be like adding a new Yankee worth of solar power every day for 50 years just to replace our existing fossil fuels, and you would have a planet covered in solar panels, and that would be totally unsustainable as well. But I'm making a separate point here, though, you're right. So we don't compete for solar power in the same way as we compete for fossil fuels. What's the limiting factor in getting solar power?
Well, first, I'm Anne. I'm a MPA student, and I'm doing the Ecological Economics certificate through the GUND. I'm originally from Vermont, and my previous experience was actually in advertising out in Seattle, and then came back to Vermont to be more immersed in environmental policy. So that's what I'm working on now. And what I was going to say is that in terms of scarcity, there's also, this brings into the conversation about scarcity for the humans versus the environment. And so when we talk about solar, we talk about alternative energy, might not be scarce for the human systems, but then there's starting to be impacts on the ecological systems.
Yeah. Yep. So that's another thing too, is that economics tend to be very anthropocentric, just focused on humans. And we've got to use resources between humans and other species. So they say that I'm talking about solar energy, which creates net primary production essentially. And there's a measure of sustainability called human appropriation of net primary product, or HAMP. And back in 1989 or 86, I forget what, you might remember, Dave, the Batusik and Ehrlich article. I forget if it's 89 or 86. They estimated that humans were capturing 40% of all net primary production. So all solar energy captured by our ecosystems, humans were capturing 40% of that. And our economy has increased dramatically in size since then.
What year was that?
89 or 86. I could look it up on my EndNote, but since then, so who knows how accurately they measured it. So that's one very important thing about scarcity between species. But the other thing I want to get at here is an important aspect of scarcity is, what is the limiting factor right now in capturing solar energy?
Well, couldn't it be like research in silicon and pieces that bring that together?
Yeah, so silicon, in terms of the most common element, or its crust, we're not going to go that, but research and knowledge and information. So really, really important. We're entering into the information, we're in the information age. And technology, you know, we're really hoping, as one of the articles says, we're really hoping on technology to solve all these problems. So if we've developed a new technology, and we have it all carefully described on you know, files on the computer, is that information scarce in any way? If we use tons of that information and generate a huge amount of solar power here in the US using that information, how much information does it leave for other countries?
I'd like to share.
Right, so that it's not, so as long as we share. So it's not naturally scarce in any way. In fact, in a way, it's, you know, what happens if we develop this great new technology and the scientists in China and India get hold of it? What are they going to do with it? Likely improve it, is what I would argue. Is that, you know, that so information is one of these things that kind of improves through use. But I would actually argue that economists look at this definition, allocation of scarce resources among alternative desirable ends, and they recognize, and this will be an important theme in this class, that there's resources that are called rival. I use it, there's less left for you to use. There's other resources that are called non-rival. And if I use it, it's still just as much as available for you to use. So if I go out there, I depend on the climate stability to grow a garden, doesn't deplete it for you. I depend on the ozone layer to keep from getting skin cancer, doesn't leave less for you. I use information, you know, the fact that there's 17 people in this class, it doesn't dilute the information at all. You know, so it's, these things are non-rival. My use does not leave less for others. But economists are so obsessed with this definition of scarce resources. They say that's what economics is about, that's what markets handle. So what we need to do is figure out, they literally believe that that non-rival resources don't fit into the market because they're not scarce. Therefore, we have to figure out how to make them rival. And so you can find literature about market failures and environmental problems saying that, first of all, they say that rivalry is a policy variable. It's something we can change. This is nothing in this. I sent this review out, and I claimed that rivalry was not a policy variable, that you can't affect it with policy. And the guy wrote back and said, that's not true, you can. And so a rival resource, I use it, you can't. Anybody think of a way we could make a barrel of oil non-rival? Or a glass of wine non-rival? So I can drink that glass of wine and you can still drink it? Is that a good policy tool? So the perverse thing, though, is economists don't want to do that. They want to do the opposite. They want to take resources that are non-rival, that anybody can use without them wearing out, and make them rival. So the way I look at it is there is one example I know of a rival resource being made non-rival, and in a parable in the Bible, you know, Jesus, I guess he goes to a party, and there's bread and fish, and not enough to go around, and he performs a miracle and makes them non-rival. So there's now enough to go around for everybody. And, you know, so it's not a policy variable. It's, you know, if you're an omnipotent being capable of miracles, you can do it. But economists want to do this. You'll find many books where they say they want to do the satanic inverse. They want to make the non-rival resource rival. They want to make it unusable. So, and they get confused. There's a big distinction. We'll cover this later. But so what do we do with information?
Intellectual property?
Yeah. So we patent it, and then that makes it so it's, you know, we can market it. We've made it artificially scarce. But that's not the same as making it rival. It's still, you know, we've just restricted access to it, but it still doesn't wear out through use. So that's one thing. So I want this thing about, you know, scarce resources. So is there any other ways that resources, so I'm arguing that there's a lot of really important resources that aren't scarce, but it matters a lot how we allocate them. And, you know, we allocate them towards desirable ends, and I would actually argue that green technologies are incredibly important. And it's really important how we allocate them. But the information itself is not scarce. So we've got this definition is a little bit flawed. Can you think of any other things? So scarcity is another thing, like, you know, can you think of things that are, trying to think of, so example, food, you know, there's not enough to meet all our desired ends, but is it scarce? So in the United States, we consume 3,500 calories per person per day on average. And if you give people more food, they'll eat more. So the question is, does this contribute, does this enhance the desired ends, Americans eating more food? You know, do you think it's a desirable condition that we eat more food? And yet you can, I mapped this out actually, and we're talking about agroecology and food systems and everything. As countries' incomes go up, calories per person per day go up. And it's a very clear curve. And so richer countries definitely consume more. So we're perceiving that as we get richer, we spend more money on food and consume more calories per person. Because you can spend more money on better food, but we're just consuming more bulk. And is there a desirable end that contributes to?
I think that comes back to the question of if the individual perceives it that way. Sorry, I'm
Yeah.
Jennifer Swain.
Yeah.
I'm doing a certificate here at the Gund, and I'm a master's business administration student. So essentially, I mean, within the economics definition, if it's perceived as increasing utility for the individual, then it's a desirable end. But I think when you come into the ecological economics and you look at the full system view, that's where we start to question whether it's desirable for society and whether that matters, or whether that person's health matters, whether or not they think that.
So economists, it's funny, they don't really even use the word utility much anymore. They'll talk about it, they'll talk about utils, but they're basically saying it's just subjective preferences. We're not gonna say anymore this enhances their utility. We're gonna say this person wants to eat more, and that's the only thing that matters. And by definition, them satisfying a want increases welfare. But again, this goes back to the thing here. What are the desirable ends? So what are the desirable ends we're gonna focus on? If the desirable end is your subjective preferences, and economists actually maintain that these things are unchanging. Advertising does not affect preferences at all. If it's just your subjective preferences, then that's a desirable end, people consuming more. But if we redefine desirable end, if we think, well, maybe there's other desirable ends, maybe satisfying, your individual preferences, which might be misplaced. I mean, I saw an ad once when I was a little kid for Twinkies, and I'd never had a Twinkie, and I thought, man, that looks good. And I hopped on my bike, pedaled down to the store, bought a Twinkie, took one bite, and threw it out, and I've never had another Twinkie because I thought it was gross. But it was like, I perceived that, so the advertising affected my preferences, and I went down there and then realized, okay, maybe not. But the thing is that if so we're gonna, this class will focus a lot on what are the desirable ends. So the basic points I wanted to make is that whether or not a resource is scarce depends on how we define desirable ends. And I would actually argue that if we went back to the traditional definition of desirable ends, meaning, increasing social welfare, making people better off, improving utility, then a lot of things we consume more of and compete for aren't really scarce because they don't make us better off. And even if you look at, you go up on Spear Street, each new mansion has to be bigger than the previous mansion. And, but is it because their space is scarce? Houses need to be bigger than that. I mean, my house would fit 4 times over into one of those. And, so there's this, so we'll talk a lot more about that too, but I think we have to really carefully think about scarcity, and I think it's an inadequate definition because of resources like information, but also because we perceive the things as scarce that really aren't.
Is there a place for capitalism and the benefits that it brings to an economy within ecological economics?
Yeah, absolutely.
Okay.
Yeah, so the deal is though, and again, this is one of the very powerful things, that there's an awful lot of good ideas from conventional economics. And market economies are phenomenal. I mean, if you think about the logistical challenge, if you were a centralized system trying to arrange for food supply to New York City, so at any given time, New York City probably has 1 week of food on supply. And yet, somehow, they bring food in from the entire planet, get it to all those little stores, get it to all the households and all the refrigerators at a reasonable price. And there's no centralized planning, it's individual choices. I mean, that's an amazing system. So I don't in any way deny that markets are phenomenal at doing certain things. I do deny that markets are the ideal system for everything. So if I said to you, well, let's, like politics, it's so inefficient. Why don't we just do it market-based? We can just buy and sell votes, and then we can, which we kind of do anyway, but, you might say, well, that's inappropriate. We don't want to extend the market into the political sphere. We don't want to extend the market into the human rights sphere. We might want to, maybe we don't want to extend the market into, our natural ecosystems and these other, so basically, I would argue that markets are a very, very powerful tool, but so it's later on today, I'll get to some newspaper articles, so I want this to be related to current events, but Henry Paulson, who was the Secretary of the Treasury under Bush when our economy imploded in 2008, he was just had an article talking about TARP and Toxic Assets Relief Program. And he basically said that, the whole problem is caused by government policy. He was essentially implying that markets are perfect. It's when governments get in the way of markets that bad things happen. So we have a religious conviction in this country that markets are perfect. When I did my PhD, I don't refer to it as my doctorate, I refer to it as my indoctrination, because I was taught with religious conviction that markets are the way to solve all problems and everything should be integrated into the market model. This course, rather than saying all resources should be integrated into the market model, we're going to say economic institutions should be adapted to the specific problems we're focused on. Markets are a great economic institution for some types of problems. They're a terrible economic institution for other types of problems. And we want to, this is not a class in religion that markets are always best. This is a class in economics, what I would like to more economic science. Let's figure out what's the problem we want to solve, what are the resources we have available. Based on that, let's figure out what allocated institution is most appropriate. So that's kind of the approach of this class. And it's not just scarce resources, partly because, mostly I would say because of these non-rival resources like green technologies. So the other thing is, what's allocation mean? And this is a specific definition for economics. Anybody know how economists define allocation? Versus distribution, for example. These are two big topics. So if you've never heard it, so distribution is who gets what. So for example, how should we distribute the oil supplies in the United States? So these were created by nature. They were not created by anybody's, entrepreneurial ability or hard work or capital investments. The oil itself was created by nature. How should that be distributed? People know how it is distributed? Differently in different states. But Alaska has said oil belongs to all of us. That was a gift of nature, belongs equally to all Alaskans. Any oil company that comes and extracts oil from Alaska has to pay the citizens of Alaska for the right to do so. It goes into a permanent trust, and the revenue on that trust is distributed equally among all Alaskans. So they've said, that's the distribution issue though. Who gets what is distribution. And we can think about who should get land. I think of land as a shared asset of society. Who should get it? Why should some people have vast swaths that they've inherited? Why should others have very little? That's another issue we can think about. But that's distribution. Allocation is what gets what. So we have land. Who gets what? Who gets land is one thing. How that land is used is another. Should that land be allocated towards buildings? Or should it be allocated towards agriculture? Or should it be allocated towards, waste dumps? Or pavement? What is that land transformed into? When we have a bunch of steel, is that steel used to produce buildings or computers or bridges or, so allocation is what gets what. Distribution is who gets what. And that's, and again, I said, scarce resources, available resources, we already talked about that. And other question, and this gets back to the earlier question of oil, how do we decide, who gets what is one thing, but how do we decide, for example, if we're looking at oceanic fisheries? So one question is who is entitled to the bluefin tuna? And to harvest, let's say who's entitled to harvest the bluefin tuna? And the other question is how much are they entitled to? So this is kind of, how do we decide how many resources are available to be allocated? Or we can take a look at another example, allocation of the forests in Vermont. We can allocate the timber towards producing tables or producing buildings. What else could we allocate that towards? The forests. Recreation. What else?
Energy.
Huh?
Energy. Burning.
So energy for burning, but what else, another thing that forests do?
Stabilize soil and provide microclimate.
Stabilize soil, provide microclimate, filter water, regulate atmospheric gases, provide habitat for biodiversity, recycle nutrients. So there's a whole other array of things we could allocate that forest towards. So one big question then, and it's ignored conventional economics, focuses on how do we transform the timber from the forest into different economic products. Maybe they'll focus a little bit on recreation, but how do you decide how much timber should be allocated towards economic goods and services, and how much forest should be left intact to provide ecosystem services or ecological benefits. How does the economy decide that? The current capitalist economy.
Price poorly, they don't.
And what's the price of a stable climate and of flood regulation and?
Zero for most businesses, and it doesn't do anything for humans.
Yeah. Well,
in a monetary sense.
yeah. Well, although actually, if you just look at flood, for example, 1927 massive floods, or actually just Irene, the flooding in Irene. One of the reasons Irene flooded so dramatically is because in the 19th century, mid-19th century, we decided our rivers were too crooked because, Vermont's very mountainous. You need land for roads, you need land for railroads, you need land for farming. The available flat land was by rivers, which used to meander all through Vermont. You look at a map from 1825, all these meandering rivers. You look at a map from 1875, all the rivers run straight. And that was to create more land. So we took away ecological functions to give us economic benefits. But as a result, when you get Irene, there are no meanders or floodplains to absorb that flood water, and it just goes charging down and taking out roads and bridges and everything else. So, and there is an economic value to that, but it's one that is extremely difficult to express in a market. And if we can't express it in a market, so I would argue you could look at, so let's say we want to look at the value of things, but markets only capture one type of value, and there's certain requirements for markets to show a value, and they don't show these other values. So the other big thing is, so that's between alternative uses. How do we decide how much forest should be allocated towards economic goods and services, how much for ecological goods and services? And another thing is like with oil, we're going to allocate it towards, we're going to burn it now or in the future. But how do we decide how much we get to burn now versus how much we get to burn in the future? How do markets decide that?
Oh, well, I was going to say that it's not through market mechanisms, there's also policy mechanisms that will decide allocation of resources.
Yeah, but so what's the policy on allocating oil?
I don't know.
And Eduardo? Yeah.
I'm Eduardo, I'm a PhD student at Rubenstein School. I sit here at the GUND. I got my undergrad in economics and my master's in forestry and natural resources. And ecological economics was what brought me here, actually. So I would say there isn't a policy for oil in the future. I mean, it is purely defined by the market, and that's based on demand and supply.
And markets are based on, demand and supply. And again, demand though is, the basic point is, the future has no demand for oil right now that can be expressed in a market. The future can't possibly take part in today's market. So the demand is based on the demand of this current generation. And what means the supply is entirely owned by this current generation. So, so these are issues we've got to think about. And, whether or not you think that's suitable determines whether or not you think we need a more ecological economics. You want to introduce yourself?
Yeah, so my name is Margarita Fernandez. I'm a PhD student in agroecology in plant soil science. Let's see, I've been doing this for 2 years now, a PhD, and before that I worked for about 15 years throughout Latin America and Southeast Asia in sustainable agriculture and food systems and farmers' rights issues. And I'm really interested in ecological economics because, we do all this work about improving food systems and improving livelihoods, and we sort of have concepts and strategies for dealing with the natural side and the social side. There's examples. And for me personally, the economic side, I feel like there's less examples of it on the ground, and I want to sort of try and translate this to, say, a farmer household. How do we take the concepts and the principles from ecological economics and put them into play on the ground with households, and then how does that translate up to policy? And so I feel like I need to be better versed in ecological economics to be able to talk about this. So I wanted to ask about where does the speculative markets come into play with future not being present in neoclassical economics?
So speculative markets, I actually argue, and we'll make this case later on because I think it's a very, very important point. Mm-hmm. So economists make the case that when a resource becomes scarce, the price goes up and demand therefore goes down. So it's a negative feedback loop. Negative feedback loops go to equilibrium. Economic theory, conventional market theory, is based on it's called general equilibrium theory, a Walrasian general equilibrium, and that's kind of the key defining thing. So neoclassical economics I'll talk about. and it's a shifting ground. And if you pinpoint, if you say there's this thing about neoclassical economics that I don't like, you know, the assumption that all people are rational and self-interested, they'll say we don't have that assumption anymore. Or you'll say that you know, or that markets are perfect and there's perfect information, they'll say we don't have that assumption anymore. So they really do teach those things, but it's not universal. So they will say that you're attacking a straw man. But what is universal is the belief in a general equilibrium, that prices are the fulcrum that balance supply and demand to lead to an equilibrium economy. And it's based on this idea, price goes up, demand goes down in a negative feedback loop. Speculation, when price goes up, demand goes up, leading to an increase in price, leading to an increase in demand, leading to a bubble and bust, the opposite of an equilibrium. And that doesn't fit into the market model and is largely ignored. And what the economists have always said is they say the efficient market hypothesis. Markets are perfectly efficient, and all these increases and decreases actually reflect the real values, and it's not speculative. And there's an article I can show you guys, it's just too stupid for me to even put on the reading list, but a guy even says that the tulip bubble, when the value of a single tulip bulb in Holland was worth more than a year's wages, he says that actually was an accurate reflection of supply and demand, and not speculation. And that, and so the economists try to persist with this theory of the efficient market hypothesis. I would actually argue that market models are based on negative feedback loops. Speculation is a positive feedback loop. And I'll make the case later on in this course that we are creating the perfect conditions for speculative economies. And there are certain very clear conditions that are very clearly evolving. And this isn't written, I've written this in a new paper, and people say, you gotta cite this. And how do I cite it? Because it's not, but anyway, so there'll be some ideas in this class that are not like out there in the literature, and I think that's a really important one. I want to work on it. So speculation, I think, is a huge problem. So so actually, I should say what my plan was for today is to spend, you know, like the first hour discussing what is ecological economics. Second hour, kind of going over the logistics of the class. And third hour is discussion about the readings, although that will somewhat come in here too. So just so you know how class would proceed today. But I actually vastly prefer to hear from you guys. So things are flexible if you guys are engaged in the discussion. That's where we're going with it. So another question is, you know, how do we decide on distribution? So so you haven't contributed yet.
Ariana.
Ariana, okay.
I'm an incoming master's student in Vincent School.
Right.
Interested in the social side of ecology and how it affects communities, but I'm also very interested in the economic side because I do believe what you were saying earlier, that we do need a better representation of the social sciences and the economics contributing together to make a sustainable community. On distribution, I would say that right now it's more like, for me, like policy-related distribution, like what we decide would be the better for the community when we decide what to do with a piece of land that would make the best profit, at least in this type of economy in the U.S.
So, so distribution is not so much about what generates the most profit, but who gets that profit. So for land, how do we decide who gets land? How do we decide who gets access to the oil? How do we decide who the air belongs to? You know, who has the right to pollute? How do we decide those things? How do economists talk about those things? And what in our market decides distribution? What's happening in distribution right now?
Well, would it be more based on the demand or the necessity for that land to be distributed to a particular culture or group of people?
So actually, there is one thing that we do decide some of this based on law. And law, so for example, the big debate in, I don't know, maybe the 70s or when it was. So in Pennsylvania, there was subterranean coal mines. And they dig under towns, and occasionally your towns will collapse into the coal mines, or buildings will. And so the question is, who gets the right? Do you have the right as a homeowner not to suffer from that? Or does the owner of the coal mine have the right to impose that threat on you? And what we actually do decide often in the court of law, so it's not considered, so we say, well, that's a legal issue. Law systems in the United States are based on cost-benefit analysis. And they change their decision based on what is going to generate more monetary value. So even our legal system is now focused a lot on economics. but this is a little bit of a trick question, because I want to show you, I hope this is all going to work well here. I think I was just reading this. So this is an article I was going to talk about later. And it's just an article by Stiglitz talking about Martin Luther King. And he says, while there are a few scholars who care deeply about issues that led me to the field, most were unconcerned about inequality. The dominant school worshipped the feet of a misunderstood Adam Smith at the miracle of efficiency of the market economy. So most economists don't discuss distribution in any way. They don't care about inequality. They just care about efficiency, maximizing monetary value. And as he says, it says unemployment, if it existed, was the fault of workers. So here's a Nobel laureate, Robert Lucas, saying one of the tendencies that are harmful to sound economics, the most seductive and in my opinion the most poisonous, is to focus on questions of distribution. So your Nobel laureates are saying that distribution is out of bounds for economics. So in a way I was asking you, a trick question, they say we shouldn't care about it. Or Gary S. Becker would, he says competitive labor market discrimination couldn't exist. So if we have a good market, there's no such thing as discrimination. I mean, I went to a mostly black high school, and I saw my friends looking for jobs versus me looking for jobs. And as a white kid, let me tell you, it was 1,000 times easier to get a job, regardless of how competitive the markets were. So this is one of the things that economists in general do not focus on distribution. That's changing a little bit, but so let's see if this is still working here. All right, so now this is kind of going over economics, the general ideas of economics, but now I want to look at what is ecological economics, if I can make this thing go forward. So what is ecological economics? And so you guys are coming into this class, what's your understanding of what is ecological economics? So have you?
Hi, my name is Katerina. I'm in the MA program here. I'm from Germany, and my background is in mechanical engineering and focus on automotive engineering. So I'm interested more in the alternative fuel for automobiles. So ecological economics, I guess, from the text we had read, it's that they focus on the time, on nature, and what was it again?
The one we just talked about.
Justice.
Yes, and justice. So what mainstream economists don't care about that much.
And then, so that's, so those are the big themes we'll be talking about later on, and here as well. But there's another, I would argue, the other big thing. Anybody volunteer to say one of the other big differences?
That our economic system is within the natural system, and so we're bounded by that.
Yeah. So the big guiding assumption in ecological economics is that, your economy is, I guess I can't, there we go. Your economy is within a planetary ecosystem. So your economy is sustained and contained by the planetary ecosystem, that all, law of physics, can't make something from nothing. So everything the economy produces, even information, requires real resources, and the one source of those real resources is from nature. And you can't do work without energy. You can't transform anything into an economically useful product without some form of energy. And all of that comes from nature. And the energy, some matter can be recycled, energy can't be recycled, that your economy generates this flow of economic benefits or economic wealth services that contribute to your welfare. And the ecosystem contributes this flow of ecological goods and services that contribute to our welfare. And welfare, we actually have over here outside of the biophysical world, because to a large extent, it's a psychic phenomenon. It takes place within our brains, and you can have a very, very high level of welfare with low levels of matter and energy use, or a very low level of welfare with high levels of matter and energy use. It's fairly separated. And the basic point, though, in the ecological economy is when our economy grows, when we get more people, when we get more human artifacts, it doesn't grow into a void. It grows into this finite, sustaining, and containing system. So that's kind of the basic principles. But so I would say, if that's the definition, if that's the view of what the economy is, then it kind of changes what our goals are. So, it's how do we allocate scarce resources among alternative desirable ends. I've kind of rephrased it here, which is a similar idea, but it's accounting for these constraints. You know, so that's, I mean, and so I kind of look at, that's what I look at is ecological economics. And that really brings in a lot of issues. I mean, does anybody have any differing views? I mean, there's definitely views out there that would, not everybody would agree on this. One thing I should say, ecological economics is still a fairly new field, and there's no consensus on what is ecological economics. And it's an ongoing debate. We're gonna end this class, not this class, we're gonna end this course by going over that debate. And it's a big debate, and it's an important debate. So feel free to debate. And you want to introduce yourself?
Yeah, I'm Elizabeth Palchek. I'm a first-year PhD student in the Rubenstein School, and background in sustainability, and I'm really interested in the economic argument for sustainability, so I understand it better. But back to this idea of desirable ends. So would you say that then ecological economics is striving to create a definition for desirable ends on a system, sort of a system-wide level, like I'm thinking like a planetary level? Is that kind of one of, I mean, it seems like that's where we're headed, right? That's one of the big goals.
So I would actually argue that's the first challenge of ecological economics. But it's one of these things that how we define a desirable end, you know, we think of it as a normative value. You know, it's what I actually believe that that there are some scientific underpinnings to our normative values. We'll look, example, later on, we'll look at some of the perhaps evolutionary foundations of our ethical system. And to argue that ethics is not just this purely, you know, that there are real right and wrong, and a lot of people believe the real right and wrong comes from God. I tend to believe it comes from evolution. But it's you know, that question of what's right and what's wrong is really important, and what the desirable ends are is really important. And so the scientific method says that we develop a theory, or we observe nature, we develop a hypothesis, we test that hypothesis, try to falsify it. If we can't falsify it, we've got a theory, and we keep trying to falsify that theory, and that's how science works. I would extend that to our normative values. So we say, well, here's my normative values, and these are the things the desirable ends for an economy should be. But then we test that empirically. We pursue those ends, and we might find that, gosh, that sounded like a really good end on paper, but now that we see it in practice, you know, for example, the end of, you know, satisfying individual preferences, subjective preferences. Maybe it sounds good on paper, we look at it in practice, maybe it leads to people being heroin addicts, people being obese, people making bad decisions about their retirement. So we might reassess our normative end. So it's kind of a process of defining what are the desirable ends rather than this is the definition, let's go with it forever. But I think it's kind of one of the most important first steps in ecological economics, or any economics for that matter. Because so one thing I think though, that we want this to be science-based as much as possible. You know, we really want to, so conventional economists, the way I usually phrase it is at the end of the second chapter, they tend to say, you know, through specializing in a comparative advantage, we can produce more output with no change in inputs. And that's magic. That's denying the first law of thermodynamics. You know, you can't create something from nothing. And, you know, they tend to deny the second law of thermodynamics, which is they'll show a circular system where, you know, firms produce goods and services that go to households, and households pay them for that, and firms pay the households for the factors of production required to produce those goods and services, and you have a circular economy with no resource inputs or waste outputs. And that kind of denies the second law of thermodynamics. So one thing I think economics has to take very seriously, the laws of physics and the laws of ecology, and you know what we know empirically about human nature, and so a lot of these things. So I think it has to be science-based, but ultimately, actually I don't know where that happened there. Why am I going backwards all of a sudden? I don't know. Anyway, I was going to say science-based but value-driven. So, you know, it's based on our best science, but we've got to decide what it is we want to achieve. And the conventional economists actually try to make it say it's totally objective. I think that's silly. So this gets back to the discussion, though, or the first reading. So, you know, what is ecological economics? And in Costanza's article, he made the case that one of the the things is, the biggest things is this technological optimism versus pessimism. And did you do something like that?
I have not.
Right.
I'm Martha Caswell. I work in the Ecological Economics Group at UVM, and I'm getting an Eco certificate. And yeah, I was actually really interested in this. I have a master's degree in public policy, and we talked a lot about game theory and making decisions. And so this idea about trying to figure out where people are in their camps and what that means they will then do in terms of their behavior predictively is really interesting to me. And so this idea that people are on a continuum of either believing that there can be a solution within the market to this and that we don't have to then worry about those other resources because they'll work themselves out, versus no, we have this finite thing and we have to protect it and we have to make policies or change people's behavior through incentives or through punishing them. You know, there's got to be, people won't make the right decision if you don't help them to make the right decision, is a really interesting question for me. And it goes back to this idea of how do we make something turn from individualized maximizing behavior into something that a society is going to want to do. And then if you're working to the global level, how do you work within different cultures and different uses of all of these resources and value systems. So that's why I'm here. I want to figure that out.
And that's what, those are very hot themes that you're in the right place.
Okay, good.
But so, do you want to, so what was this technological optimism versus pessimism? Because this is the way Costanza I don't think he would do this anymore, but back in 1991, this is the way he framed ecological economics.
Right, so one is the idea that there is a technological solution to any of these challenges. So even if we're approaching the end of oil, it's okay, because we're going to be able to figure it out within the market, something that can be a substitute or something that we can do that will allow us to keep functioning at this or a better level to infinity. And then the opposite of that is, no, we have a finite amount of resources and we have to limit their use or figure out how the price is going to go up enough that we're gaining additional resources so that we're putting it back into the system. And so you can't have both, is how I understood his argument.
Yes, we get it. And I should say there, on the technological optimism, there is a little bit of a division. So there are those who really believe there's absolutely nothing to worry about, that we will develop new resources as we go, and you know, that global climate change, no big deal, geoengineering, all this stuff. And there are other people like Amory Lovins, and to a lesser extent probably Hunter Lovins and Paul Hawken, who basically argue there are very strict ecological limits. But technology is so amazing that once we force, the entrepreneurs to account for those limits, they will develop all the solutions. So, we'll have really lightweight hypercars that run on hydrogen and don't pollute, and, so the technological optimism is some who believe we don't even need to think about limits at all, and others who think that we gotta force society to accept those limits, and then technology will step in and just solve the problems.
So is that like a reactionary sort of stance? Like when the world goes to shit, technology will come in, sort of?
Well, and did you introduce yourself?
No, sorry. I'm Jeff Castle. I'm in the CDAE master's program. I have a background in geology and economics, and so I'm sort of here to bridge those two disciplines a little bit.
Okay.
So, I mean, is that sort of technological optimism that, like, you have to force people to come up with the innovation? I mean, but that's sort of like a after the fact sort of?
Well, so what they're saying is, they're trying to do it before the fact.
Yeah.
So Amory Lovins has been, and there's this book, have you ever read Natural Capitalism or heard of it? Mm-hmm. Yeah, so it's one of these books that really says, we can solve all these problems, we've got to do it before the fact, is what they're really saying.
Okay.
But they're pushing for that. So I would actually argue they've got the right idea about our ecosystems,
yeah,
but have tremendous faith in technology. Mm-hmm. And so I should say that this summarizes itself, actually Skylar is the last person who's part of this class as well, not just the videographer. So Skylar, have you heard these phrases, weak versus strong sustainability? You know how they fit in?
Yes, and I kind of forgot.
All right. So we may as well introduce yourself right now anyway, and you can contribute on another thing.
Yeah, I'm Skylar. Did my undergrad here and did some ecological economics, and now I'm a first year CDA student, and working with Josh some, and really psyched about ecological economics.
All right, and I'll just put this, weak versus strong sustainability kind of fits into this technological optimism versus pessimism. I think the phrase might have been coined after this article was written, but you'll see it a lot. So weak sustainability is what conventional economists believe, and that essentially all resources are substitutable. So there's relative scarcity. You know, oil might be scarcer than coal, but there's no such thing as absolute scarcity. If we run out of fossil fuels, we'll just develop another substitute. And our obligation in terms of sustainability is to leave future generations enough capital to have as high or better a quality of life than we do. But capital can be natural capital, you know, our stocks of natural resources and the services they generate. It can be built capital, our buildings, et cetera. It can be human capital, knowledge, technology, or it can be social capital, you know, strong social networks and interaction and trust. We have to leave some combination of those capitals that makes people as well off as they were before, but they believe they're all perfectly substitutable. So that if we completely wipe out our natural resource base, no harm done, as long as we have invested that in substitutes from other capitals. And that there is nothing special about nature or the environment. Strong sustainability says that, you know, humans, like all other species, depend on a well-functioning ecosystem to survive, and we have certain critical thresholds we cannot pass within our ecosystems. And so we have to respect those thresholds and treat natural capital and recognize that all natural capital is the precursor to all other capitals. And some people are offended by this use of the phrase capital and say it implies an effort to insert everything into the market economy, and I don't treat it that way. I think it's a useful phrase, and no way in my mind does that imply everything should fit into the market economy. It does in my mind imply that economics matters to how we manage these resources. And capital is a stock that yields a flow of benefits, and so I'm not, I use a lot of these phrases that people get pissed off at, ecosystem services, natural capital, because they argue that it implies we're trying to force everything into the market. I don't believe we should force it into the market. I do believe the phrases are useful.
I have a question going back to technological pessimism and optimism. Can you technically argue that technological pessimism would discourage from venturing out to other forms of resources once you start thinking like, well, we have oil, we need to conserve it, let's focus on that, and then we get so caught up in that that we don't think about, oh, how about we use solar instead of oil? Or is it more of an idea like, let's conserve but also find other sources?
So the way I view it is the rule we should be applying is we don't use, you know, so technological optimism means we will develop the capacity to solve a problem in the future. I actually believe that if we're using our oil, we should make sure we're investing enough of the profits from oil into alternatives to dramatically increase the likelihood we will develop a substitute. And ideally, you don't want to deplete your resource faster than you make progress towards developing a substitute. The thing here is the energy sector in the US invests 6% as much in R&D as the manufacturing sector in general, so which is 0.03% of sales. So they invest almost nothing in R&D. And the assumption is that if suddenly resources become scarce, you know, that we can instantaneously develop a substitute. We don't need to invest in it ahead of time because instantaneously it will happen. So, you know, so it's so there is the people who argue though for technological optimism. They say that if we don't go full steam ahead, we won't develop the capacity to create the substitutes. So Jevons back in 1830 or 40 did a study on coal in England, and he said it's finite resource, and so valuable there's no conceivable substitute, and therefore we have to conserve it. And some people say, well, if we'd listened to Jevons, you know, it would have ground the Industrial Revolution to a halt, and we would still be way less developed than we are now, and we wouldn't have the capacity to do nuclear power and extract these natural gases and hydrofracking and all this other stuff. So had we listened to him, we would be worse off right now, and people would be living worse. And so, you know, so we've got to pay attention to, you know, so we've got to use our resource base, and that's the secret to success. So this guy.
I was just wondering if you could talk a little more about that. I feel like there's a lot of people that are saying, you know, like at this point we're not going to be able to stop climate change, say, for the next 60 years or whatever. We're not going to see any changes, so it's almost like at this point we should just be investing in trying to make sure that we can live with it.
And so this is a big issue. So there's a book I used to send my students called Believing Cassandra by Alan Atkinson. And I'm told this is not a good representative book of his, that it doesn't necessarily even represent his beliefs. But he's talking about all these, you know, Cassandra was the one who foresaw the future, but nobody believed her, so the disasters came to unfold anyway. And what he's saying is that the environmental economists are the Cassandras. We're saying all these, I'm sorry, not environmental economists, environmentalists are the Cassandras. The technological pessimists tend to be the Cassandras saying all these bad things are going to happen. And so he lays out this case that, you know, systems thinking, good worldview, limits everything. And at the end, though, his last chapter, he says, but you know what? I like to fly around the world and stay in fancy hotels and live in a big house. So our only option is, you know, our plane is heading toward the mountain right now. It's going to crash. What we've got to do is accelerate to get enough speed to go over the mountain. And so he ends up saying we've got to invest in the technological optimism solution. And I think my own view on this is that, you know, if you look at the history of it, there's always been these technological pessimists, starting with Malthus and, you know, and Jevons and Ehrlich, always saying we're going to confront these resource constraints, we're going to have massive famine and suffering and deprivation if we don't do something about it. And so far, they've always been wrong. Technology has stepped in to save the day. I would also argue that almost in all cases, the technology that has stepped in to save the day is the use of fossil fuels. And fossil fuels are finite. And so we're really not talking about developing major new substitutes for everything. We're talking about finding more and more uses for fossil fuels. But that if we act as technological pessimists, that means we slow down resource use, we invest a lot of the profits from resources into developing alternatives. It gives us much more time to develop alternatives. And more, my view is, Costanza says that if we act like we're technological pessimists and it really is a world where the optimists are right, that's acceptable. I would actually argue that the more we act like technological pessimists, the more likely the optimists are to prove right, because we give ourselves more time and a better resource base and plan ahead to develop those solutions. So in a way, I think if everybody says, and this is one of the things that you listen to the economists, and so I had a debate with a couple of neoclassical economists, and they were arguing, you know, essentially there are no environmental problems, everything's getting better. And I would actually argue one reason things are getting better is because we passed the Clean Air Act, Clean Water Act, where the government said you can't do these things anymore. We force you to try to develop these solutions. And they were saying we should just have no, their reasoning was because everything is getting better, we should have no government intervention. My view was that because of intervention, things get better, and the more you have people step in to say you can't extract resources, and you have to develop alternatives, the more incentive we have, and the more likely the optimists are to be right, and the more likely future generations will look back and say that Farley guy and those ecological economists are idiots because we solved all these problems. But nonetheless, I would rather be looked at as an idiot in the future because we were acted as technological pessimists now.
Doesn't this kind of act in a larger sense as the same way that speculation and futures would on a small market, but instead now it's on that absolute resources? So if we expect, like if you look at as the price of oil goes up, more hybrids are created.
Yeah.
But that's only oil.
Yeah.
And we talk about the positive feedback loop in that, and how that could create bubbles and whatnot. Can't that kind of be applied in a way to all of the natural resources? And now all of this is kind of speculation.
So one way to look at it, I speculate, I buy a resource now and hold it off the market, hoping the price will go up so I can sell it for more. So if I actually believe, if I'm a technological optimist, and I believe that if we hold oil off the market, they'll really quickly develop substitutes,
right,
then the price of the oil will fall. So if I'm holding oil off the market as a speculator, and I see a sign of a new technology coming on because the price of oil is so high, I will think, well gosh, when that new technology comes on, it's going to crash the price of oil, and I will be holding this asset, so I'm going to try to sell it as quickly as possible. But if I am the speculator, see the new technology, sell my asset, drives down the price of the asset and reduces the incentive to create that new technology. So essentially you get this, what you'll get is, you know, wildly cyclical prices. And I would believe that developing new technologies and, you know, in a market depends on a fairly, that you have a good expectations for what future prices will be. If you think future prices will crash, well, I sure don't want to waste a lot of money in developing an alternative now. So I actually think speculation undermines that, but that's you know, most economists will say, no, speculation does exactly what you're saying. And
Well, it seems like it's a balance of the two.
yeah, well, and it all depends on whether, you know, so speculation leads to bubbles and busts, so wildly fluctuating prices. And I don't have it right now, but I do have it on my computer, but pictures of variations in oil prices. So like in the price of oil might vary by more than 5%, more than 30 days in a year. 5% variation in one single day. And that's like a wild variation. And it's really hard to plan ahead under those circumstances. And it is a fact that oil prices are one of the most volatile prices in the economy, and there is less R&D in energy than almost any other sector in the economy. I mean, there's more R&D into hearing aids than there is in oil as a percentage of sales. I mean, it's just, you know, for whatever reason we decided oil is not important enough to, you know, energy is not important enough to invest in. I don't know. It's a good question. So it's yeah. So those are, so, you know, some of this, and I don't know, what are your views? What are you guys' views on this? I mean, how often have the technological pessimists proven wrong?
Mostly. It's also a vision, a question of the scale in which they were wrong, though. I mean, you might have transitioned from coal to another form of fossil fuels, but at what scale were their predictions wrong? Yeah. The world might not have collapsed into chaos, but this ecosystem that the mine where the fracking well went into was essentially destroyed, and like the people living above the well or something like that are negatively influenced. So it's really an issue of scale. I mean,
Or climate change.
Yeah.
I mean, that kind of trumps it all on some level. I mean, so I agree with you that it's like these dire predictions may not have been quite right, but if you look around, there's a lot that's, you know, a lot of loss of biodiversity and climate change and, you know, changing a whole planet based on our actions. So I guess it depends on how you define it.
And another way to look at it is perhaps as a result of these dire predictions, we invested a lot more in solutions.
I'm guessing that we could probably make a generalization that the pessimists who tend to be more focused on the natural world anyway tend to be correct about the predictions involving the natural world, but that when they venture into the social world and make predictions about humans, that they've historically tended to be totally wrong on an extremely global scale. I mean, mass starvations of millions of Indians because of widespread famine did not happen in the 70s and 60s.
Yeah.
But where are externalities in this? Like, I just feel like, so sure, technology looks like it has solved everything, but there's all of these other things that aren't getting valued in that equation, and no one's paying. Like, in that little box, no one's paying for those damages to the ecosystem. And so, in truth, is it that they're right? Or is it just that we haven't gotten to that end? I mean, I guess maybe I'm a pessimist. I'm hearing myself, but, you know, on NPR the other day, they were talking about this technology that they're developing that's to make volcanoes that can shoot little pieces of reflective matter into the air to simulate real volcanoes, because real volcanoes provide insulating layers and protect the ozone and do that. We have no idea if we create that, what it's really doing. And they were also talking about these big vacuums that'll suck carbon. I mean, really?
Yeah.
Like, maybe, but I also feel like we can sit here and see hindsight and know. And so we can make a judgment about that was a good decision, that wasn't a good decision. But when we're moving forward, it seems much harder to have that predictive ability to say, we understand the full scope of all of the impacts that this action is going to take.
Karina?
Ariana.
All right. Yeah, it'll take me a little while to get, once I've got, you know, I know a bunch of you, but it'll take me a little while to get everybody's name. I knew it ended with an A and it had like this.
You know, well, just adding on to that as well, I feel like if you look at it from the technological optimism perspective, it doesn't give us enough time to really divert our resources and research into the particular energy sources that we're using to better the previous one, right? So like the case when it comes, for example, we are doing all this oil extraction, we go into fracking, and now we're finding all these externalities, like she was talking about, not necessarily scientific, but also negative social impacts that are happening to the communities that are getting fracked. Or we talk about food, we start talking about GMOs, and we really don't know, we don't have the research to say, yes, this is ultimately a better source. And on the pessimism, it might take longer to find these resources, and it might be more expensive in the short run, but eventually we might be able to find a more effective form of energy that we take into consideration all these aspects that we're kind of like just trying. And also I do believe that in such a competitive market that the US has, we're just trying to better find the next source of energy faster than anyone else without taking into consideration the negative externalities to our social communities.
And actually one comment on how competitive our market is. How competitive are our markets in oil? So economists typically say that if you have fewer than 5 firms controlling more than half, I think, of your supply, it's not competitive. And by their definition, so how competitive is our market in oil? And what would happen if an oil company developed a cheap, clean, pollution-free substitute for oil? What would happen to the value of all their oil stocks? Which are plummet. Would plummet. And
so they would become phenomenally rich.
That one firm would.
They always are looking for game-changing technologies, though. Oil companies, I think, build that into their strategy because they're building uncertainty and the potential for what they would call game-changing technology. But they're not investing in it and making it, and nor do I think that they are responsible for that personally. I don't think that they need to be responsible for changing the technology. I think that there's other ways that we could change technology, but I agree with the idea that we don't know the system's effect. Like we continually are like, as humans, like this new great thing, oh, it destroys these other things we didn't think about. So, you know, I guess I would be kind of potentially in the middle if we're putting ourselves in a placement here on some kind of spectrum. But oil companies are not people that I believe are responsible for changing the technology.
Yeah, we know empirically they invest less than almost any other sector. And I have a lot more to say on that later on. But and then Anne and then Brian.
Well, I was going to say with the technological optimism, it seems that because of the competition to develop, like I think it's a very pressured system where technological optimism exists, and therefore it tends to be more of the weak sustainability. And I think what you said earlier about the investment in solutions, I mean, I think that's kind of on the technological pessimism side. For me, if we can develop technological responses to things like, you know, I was just, you know, yesterday they released the amount of money that we've had to put into Vermont for recovering from Irene, you know, and you look at, like, I don't see that as technological optimism necessarily if you're spending millions of dollars in trying to react to challenges as opposed to planning for a longer sustainability.
Right.
Well, yeah, along those lines is dichotomies scare me. So it would seem to me with, you know, half of my first class under my belt, that it's up to ecological economists to kind of act as a mediator and maybe work to incentivize the technology creators before a natural motivator has to take over.
And I would say that's kind of my view is that, you know, the more we act like the pessimists are correct, the more we're going to invest in solutions, and the more likely the optimists are to be correct. The more we act like the optimists are correct, the more likely the pessimists are to be correct.
I was just going to make 2 points. The first one, I think one of the main reasons that the pessimists get proven wrong is that the main measure of progress is GDP these days. And if you look at a study, The Limits to Growth, which was written in the 70s, and which they made an updated version, I think, in the early 2000s, where they looked back at what happened in the previous 30 years. They see that a lot of their predictions actually did happen.
And last year somebody did another update to check it out.
Right.
Unbelievably on target.
Exactly. So not always proven wrong. That just depends on what you look at. If you look at ecosystem services that are externalities, like she's saying,
and if you look at, another thing you would look at is, for example, the ecological footprint, which in some ways is a flawed technology, but what it's saying is, to what extent are we living off the flow, essentially the annual interest, the annual new production from our ecosystem versus the capital itself and the stock. And we have, in fact, Overshoot Day was earlier in August. And that is the day we stopped living off the flow and started digging into the capital. And if you're looking at, so if you're a trust fund kid and you got $1 million in the bank and you say, you know, I don't have to look for a job, I got plenty of money, and you know, I'm getting some skills, and eventually at the end when that thing's out, I'll just find a job then. But as your trust fund is going down, you know, so kind of what we're saying, if you say that technological optimists, you can't really say they're right because our overshoot has gone up and up and up and up. And so, you know, what we can say is we can hope they're right because we're clearly, you know, going to have to, when we deplete our capital base, that's when we're going to have to find the solution, and we're not going to necessarily have much time.
I have a question. Is pessimism, would planetary boundaries approach fit into the pessimistic scenario? Is that kind of the same thing?
Actually, no, and that's another thing I had, and it was, but very much, forget also, was other elements, and that was ecological optimism or pessimism. So he doesn't talk about this, but I actually think it's kind of relevant. You know, to what extent are our ecosystems resilient and capable of, you know, adaptation? And I would think that, you know, that might, so planetary boundaries might fit a bit into the ecological pessimism. I don't know, I was just thinking about this, and I was actually going to suggest other elements of EE, and you kind of brought this one up. You know, because some people basically believe our ecosystems are just insanely adaptive, and there's almost nothing we can do. And to some extent, I believe that. I just believe the time scale might be 10 million years, and the lifespan of humans is, you know, dramatically less. And, you know, I don't think any way can we, you know, destroy life on Earth. You know, I think life is unbelievably persistent, and that we can have, so there's people know about the Paleocene, Eocene thermal maximum, which is a 9 degrees centigrade change between the geological eras of the Paleocene and Eocene. You know, rapid 9 degrees centigrade change, so more than we're talking about with climate change, or more than we're talking about in the immediate future with climate change. And, you know, unbelievably disruptive. But it likely led to the evolution of our ancestors, and ultimately resulted in us. So, you know, huge disruption, but on the scheme of things, you don't even hear about it because it's kind of, you know, wasn't as big as some of the other extinctions and stuff. But so that's, so on the long term, I'm an ecological optimist, you know, we can't screw with life. On the short term, I'm a little bit of an ecological pessimist that I think we have very finely tuned systems that we can send over a threshold and they can crash, and with unbelievably little warning, you know, before things flip. But
one thing, I don't know if this is a separate thing to what you were just saying, but in reading about technological optimism or pessimism, whichever one you are, it still is divorcing itself from all these other things like social theory and human behavior and political systems and social systems. And so I feel like ecological economics does take these things into consideration, so they are different from just being put as a technological optimist or pessimist, but taking into consideration all these other structural system things that need to be changed in order to become more in balance with I guess it's not growth, but a better well-being of society that's not dependent on infinite growth. And so here, I guess you bring it up here with the ecological optimism or pessimism, or social optimism or pessimism, or political optimism or pessimism. And so of all of these pieces that make up our society and our social ecological systems, needing to look at all of these parts as optimist or pessimist, and how do we balance and change these things.
So Bob Costanza actually did a later paper, which is kind of cool, Future Visions, and he does the same thing, technological pessimists. We are technologically pessimistic. Or, you know, we're pessimistic or optimistic, and the real state of the world justifies the pessimist or the optimist. And instead of, you know, his thing, so he says, if we act optimistic and the optimists are right, we get Star Trek. And if we act optimistic but the pessimists are right, we get Mad Max. If we're optimistic, if we're pessimistic and the pessimists are right, we get Ecotopia. And if we're pessimistic but the optimists are right, we get big government. And so I thought it was a more, you know, because it brings in some of the social elements and brings in, you know, I think it's a more interesting, but he wrote that, you know, a couple decades later. So, you know, so this other thing is like, so one thing that's very, very interesting, to be honest, this class, you know, I love ecological economics, and I typically have enough material prepared in any 3-hour class to go for about, you know, half a semester. But there is one thing I did want to bring up because I think human behavior is really, really important. And there's this thing called social theory, and it's so cool, I think, that there's this idea that you have, you know, this is grid, and this means how much freedom of action is there. Do we have very limited freedom of action or broad freedom of action?
Use a different marker.
All right, and so, you know, so we have, oh, yeah, this might work better. So this is essentially freedom of action, and here is group. And this is, are we individuals, you know, really, you know, independent individuals, or are we members of community? Are we people in society? And you ask people where their views are on grid and on group. And if you believe that we're very, very individualistic with a lot of freedom of action, this is like the libertarians, you know, free market economics. They fall into this category right here. And if you believe that we have a lot of freedom of action, but we're really a group, then you get egalitarians, which is, you know, this is kind of like the hunter-gatherers, the egalitarians. If you believe that we're individuals, but there's very little freedom of action, then we're the fatalists. And, you know, we have very little control over what happens, and we're in it as individuals. But if you believe in, you know, that we're in it as a group, and there's very little of, you know, we have very little choice, then it's the hierarchy, bureaucracy. And these are, so you ask people how they feel on these things. You can break it up into these 4 categories, but these correlate very strongly to ecological optimism or pessimism. And people in, these people, you ask them their views on nature, their views on global ecosystems, they tend to have this metaphor of a cup with a ball in the bottom. No matter how you shake it, that ball comes back to here. The fatalists look at it as a ball on a flat surface. Doesn't matter what you do, it's going to go wherever it wants. You have no control. The hierarchical, or the egalitarians, tend to believe it is something like this. Very fragile system, ball on the top, any disturbance could lead to crashing. And the hierarchicalists have a thing like this, that you have this, you know, within a certain range, you're pretty safe, but if you go too far, it collapses. And it's very interesting. So I'm just out of curiosity. So this is, I just think it's very interesting how that optimism or pessimism relates to these other values. And I don't know why this is called social theory. I think that's what it's called. I have no idea. I just thought this was kind of cool. I'm just curious, anybody, Sky,
yeah, I was totally thinking about this. Like, I was, speaking of trust fund kids, I was with my friend in the Hamptons over the summer. And, like, there's totally, like, that hierarchy piece is like, it's like, we're safe here, you know? Like, they could call on, like, a helicopter if they needed to or whatever. You know, it's like, there's just, like, this place, I mean, unless it goes too far, that the top 1% of the United States is probably going to survive.
Yeah. And that's true too. I remember teaching ecological economics in Australia, and one of my students says, you know, does this, you know, did you really think we're all going to do this? I think the rich people will probably do fine. She's like, oh, thank God. Or she didn't actually say thank God, but you could just see that alleviation. But so I don't know. You guys might think about where you fit into that grid group and see if it holds for you.
I'm not sure that I buy the whole distinction, but the pictures got me thinking. The one in the bottom left and the one in the top right, which are exact opposites with regard to social views, but they could be the same thing if the boundaries are unknown. And so somebody in the bottom left corner could believe that that's the way the world is until suddenly they realize that it doesn't end with that little stop. It goes down after that.
And so it's, but I thought it was a very interesting view that tied into that stuff. And so again, I should also ask how you guys want to do class. So, break. Yep. So, and as I say too, that I have, so we may recalibrate. I'll probably spend the rest of the, go over kind of the logistics of the class, but also that ties in a lot to more discussion. So, so in general, especially when you guys are engaged, and I'll tell you right now, that I was gonna bring it up later, but the way the class will work, and I've already said this, typically the first hour, I will give a presentation that's designed to stimulate discussion with you guys. So it kind of be like maybe a half-hour presentation, half-hour discussion, followed by the second hour is you guys are gonna choose individual papers related to that class topic, and we'll divide it up. So basically there's gonna be 13 more classes, 26 students, 2 people every class will give a presentation and guide discussion, so maybe 20 minutes presenting a paper and 10 minutes guiding discussion type thing, or some balance in there. But the basic idea is the classes, you guys are responsible for introducing relevant material and guiding discussion. And then the third hour, so a day before class, 24 hours before class, you're gonna have to, I think I said 36 actually, because I gotta like read through them all. You're gonna submit discussion points based on that class topic and readings. And I'm gonna choose a few of the best discussion points for the last hour, and we'll use those. But everybody will therefore come prepared to discuss as much as possible. I do wanna get us engaged. Kind of relying more on presentations, partly because there's gonna be so many of us. So with discussion, it's really hard to get everybody, you know, as I say, it's 12 people, man, this would be awesome. And you know, one way to do it would be to have 2 sections, but that would just kill me, because I have another 2 classes, and then I can't do that many classes, and I should, but universities don't. A course counts for 10% of your workload, and which is just ridiculous. There's no frigging way you can do a course in 10% of your time. It's more like 20%. Yeah.
When we break up, or we don't break up, in the second or third hour, have you thought about breaking up into 2 groups? And
so
you
in
know,
the third hour,
since students are leading the discussion?
Absolutely, I've thought about that. I think that's the way we might go. And so we could essentially break this up into 2 groups and break up the, even in the other campuses could be, because that's what I think is gonna be challenging. So so I'd like to have suggestions like that, and that's something I've definitely thought about. So we can, so as I say, we're playing this by ear. You guys are the guinea pigs, I'm the guinea pig. I don't know the best way to do a class like this, but I really wanna make it work. And that's gonna, but it seems like a really good, I gotta say, it seems like a really good group. So let's take a break, maybe 10 minutes. But what's interesting is economists, the core theories are still built on rational and selfish. And, you know, taught everywhere like that. But in this class, we're gonna take it a little bit further. So one thing is, what are the proximate causes for our behavior? What leads us, you know, what leads us to behave in a certain way? And, you know, one thing you can think of as a proximate cause is we're in this, a world where, you know, a market economy, which favors certain types of behavior. Very, very different from like some of the more egalitarian hunter-gatherer cultures, where if you accumulated more than your share of things or more than others, you could be socially ostracized, you could be poorly treated, where it was very egalitarian and you know, standing out was really bad. Whereas here we live in a culture that, you know, glorifies greed and self-interest and capturing things for yourselves. So these are proximate causes. What are the current conditions that lead you to behave in a certain way? But also we're going to look at ultimate causes. You know, how did humans evolve? And what is it that, you know, what is our genetic predispositions? What does, you know, how can those be affected? And so, you know, so my view is there are certain, we have our genetics imposes certain limits on how we behave. Culture imposes probably stricter limits on how we behave, but there's an awful lot of variety within our, you know, within both our genetic makeup. We can have different types of behavior, and I would actually argue that really powerful forces led us to be social animals. Anybody here seen read The Social Conquest of Earth by E.O. Wilson? So he makes the case actually, and I haven't read it myself, but I've read tons of other stuff related to this, and other stuff he's written, other stuff by David Sloan Wilson, somebody else, but he says that real cooperation, real eusocial or ultra-social behavior has evolved, I think, like 13 times in the history of the planet, and the descendants of those species now account for half the terrestrial biomass, or maybe total biomass. So in other words, it's an insanely successful adaptation. It might not be biomass, it might be animal mass. So, I just haven't read it. But like I have read that in the Amazon, and I don't know if it's biomass or animal mass, I think it might be biomass. The ants just account for some insane percentage of the biomass of the Amazon. But basically humans, ants, bees, you know, these, so it's one of the most wildly successful adaptations ever. And that's, you know, so that has to do with ultimate causes. Why did we evolve to be cooperative? How do we, you know, how do we create institutions that channel our behavior in certain ways that are best suited to solving the problems we currently face? So that's going to be a big issue. And, you know, what institutions exist and how can they be modified? So institutions is kind of defined typically as the rules that, you know, or it could be like the institutions, like a university is an institution, but it has a set of rules we follow here. But, you know, market is an institution. So what are institutions at our disposal? How can we modify them and, you know, use them to achieve the desired ends? And only after you really have good answers to those questions can you focus on that how do we allocate question. And I would argue that conventional economists, whatever else you think about them, if you take a course in 99% of the courses offered in the US and universities, they are going to start with the assumption that when you study the economy, you're studying the market economy, and the market is the institution we want for everything. And we force everything into the market. And we're not going to take that approach. We're going to say, let's design institutions to match the desired ends and the nature of the scarce resources, rather than trying to force everything into the market institutions. Got it?
But like, isn't the market ultimately like a cooperative behavior? Like, isn't specialization sort of the reason that cooperation is so?
There's no markets without cooperation. There's no markets without government. You know, it's one of the ironies of you need, because for example, you need private property rights for markets to work. Where do private property rights come from? They're essentially government enforced. Either it's rule of might makes right, but in which case there's no market, then the big guy comes and takes what he wants. But if, you know, you can't have a functioning market without governments that enforce contracts, that enforce property rights, that create all these other aspects of infrastructure. But it's one of the ironies of the people who say get the government out of the market. It's kind of like, you know, get the government hands off my Social Security, or was it Medicare? I forget which one. One of the Tea Party protesters actually had a sign that said, "Get your government hands off my Medicare," I think it was. So these are kind of the guiding questions for the course, and there's also guiding assumptions. So these are things you could look at them as axioms, things I take to be true, but we can debate. I'm certainly welcome debate on these things, and one thing is that, you know, the ecological economic system is inherently complex. So conventional economists model the economic system is equilibrium mathematical system, which exhibits none of the behavior of complex systems. So it all goes towards equilibrium. There's only negative feedback loops, not positive feedback loops. So complex systems have, you know, negative and positive feedback loops. So negative feedback loops are damping systems, and positive feedback loops are ones that accelerate change. And that both of these are present, that we get highly nonlinear change. You know, and this means that we get thresholds, we cross a threshold, and change is fundamentally different. It's like if you don't get enough water, you get enough water, you know, you're consuming a lot of water, you reduce your amounts a little bit. For some area there's linear change, and then suddenly you get a nonlinear change, is you don't get enough water to survive and you die. That's nonlinear change. So emergent phenomena, things that we can't predict, they're surprises, and you know, chaotic behavior and uncertainty and ignorance. So all of these things are guiding assumptions. Any questions on any of that? I mean, I'm not going into great detail, but you know, the basic idea is a complex system. And how many people know about like complexity theory, or have never heard of it? All right. So it is this whole. It really is a whole new way of understanding systems, and complexity is kind of order emerges out of chaos. Is almost the case. You put a bunch of you throw enough elements into a system, and types of spontaneous order emerge. And life is kind of one of those, you know, types of spontaneous order. So we'll talk more about this, but I do want to get to some of the core things, some of the introductory material for the class. But it's also an adaptive system, so that, things are in a constant state of change, but cultures, ecosystems, economies, technologies, everything is continually evolving and adapting. And a really important part of this is that what's going to happen, evolution is largely unpredictable. We really don't know what's going to happen. So this gets back to that uncertainty and ignorance. That, and I'll talk about this later, but uncertainty means kind of we know the possible outcomes, but not their probabilities. So risk is we know the possible outcomes and their probabilities. Uncertainty, we know the possible outcomes, but not their probabilities. Ignorance, we don't even know the possible outcomes. And I'll get back to that later today. So that we can't predict how ecosystems will evolve, we can't predict how technologies will evolve. It is considered novel, it's unpredictable. I don't know to what extent you guys agree with that. So in terms of Stephen Jay Gould once said, if you rewind the clock of evolution, everything things will evolve in new ways. And it's not, I just read a recent study, and it was basically showing that they took a whole bunch of little microorganisms and had them put them in the same condition and found that they evolved in exactly the same way. But it was one little, it was not a very complex system, but it was an article I read. But anyway, I'm making the case that we really can't predict what future technologies will be there. We can't predict ecological changes, so it's that ecological optimism versus pessimism, and technological optimism versus pessimism, largely unpredictable.
So Mary Jane and I are in a class just yesterday night with Asim Zia about decision-making models, and when he highlights the importance of dynamic, meaning that the conditions at point B, or the second point depend on the conditions of the first point, and that's very much tied to evolution. So we have 4 limbs because we evolved from tetrapods. We have a brain because we evolved from vertebrates. So would you apply that to the ecological economics, this dynamic nature?
Well, so one thing, they talk about in economics a lot, they talk about lock-in. And so one thing is, in class in 237 yesterday, we were talking about fossil fuels and everything they did and how, so we went from horses to cars in the United States fairly early on in the development of our infrastructure. And that led to a dramatically different infrastructure than you'll find in Europe. In Europe, it's really easy to have public transportation and everything because you developed your infrastructure without fossil fuels largely. And that allows us, that makes a totally different type of living space there. Here we have lock into the cars. People say it's, you always hear people saying when I came here, people said it's impossible to bike here in the winter. Just can't be done. And, but now more and more you see a lot of people disagree with that. But we're locked into a car infrastructure, and there's all sorts of paths. So we'll talk a lot about that kind of thing. But so I think what happens now, and it's kind of a basic principle in ecological economics, that we have to start with historical conditions. We have to realize where we are today and go on from there, instead of re-envisioning the whole economic system starting from scratch. Can't really do that. We're locked into certain things. So anyway, basically, I'm assuming complex adaptive systems, and subject to the laws of physics and ecology. They apply to us. We're not divorced from those laws. We are not, we're not superhuman. We really, and a lot of economists, you will read stuff actually, economists saying the laws of entropy do not apply in any way to economics, that we're anti-entropic, that we can, entropy, and we'll get into this because, but entropy is basically things tend towards greater disorder, and I was just talking to a physicist who's a specialist in entropy, and he argues that the way ecological economists talk about entropy is not quite right. So we'll talk about that too. But basically, a lot of economists say that this is not true in economics, and I actually disagree. I think that we are subject to physical laws. And I think another big point before I move on to stuff is just the transdisciplinary nature of economics, of ecological economics. And then I'll go into course material, or laying out the course. But so this is not, so one problem with this, the way I started out, was what is economics? as though ecological economics is economics. But ecological economics is really, you know, basically it boils down to believing the economic system is a subsystem of the social system, is a subsystem of a finite planet. And if you have that belief, that's ecological economics. More so if you believe that that leads us to pay attention to sustainability and justice. But you do not have to be in any way an economist to be an ecological economist. And in fact, the economists are the distinct minority here at the gun. You know, I'm an economist, John Erickson's an economist, Asimzi has done some economics, and I think that's the lot of us. And everybody else is, you know, natural sciences, computer sciences, you can be law, it does not matter. So when I say transdisciplinary, does anybody know what I would, you know, you've probably heard of multidisciplinary, interdisciplinary. You guys know of any distinctions between any of that? Yeah.
I would say multidisciplinary is the bringing together of different disciplines and having different people from different disciplines work together, but not necessarily one knows a lot about the other one. And then interdisciplinary would be where there is a little bit more crossover between the different disciplines. And then transdisciplinary would be including the academic disciplines as well as non-scientists, like other types of knowledge, like farmer knowledge or you know, whatever other type of people you're working with that aren't academics.
And I would add to what she said actually is that you know, multidisciplinary and interdisciplinary discipline is the leading thing. You know, I apply my knowledge of economics to whatever problem I address. Transdisciplinary, I would argue that the problem, you apply whatever methods are necessary to address the problem. So the problem determines what knowledge and information is useful, rather than and I had this debate with my advisor in grad school. He said, "Why are you studying ecology?" And I said, "I'm looking at, you know, deforestation issues in Amazon. I need to understand the ecology." He said, "No." I said, "I need to understand, you know, the problem determines what I need to study." And he says, "No, you're here to apply economics to any problem. The discipline determines what you study and what you do. Transdisciplinary is the problem determines what you study and what you do." So that's the way I argue it. Yeah.
Why is it that it's kind of dismissed in some circles? It was mentioned in one of the articles that as soon as you say transdisciplinary, you're dismissed. Is that an issue of specialization or?
So it's interesting that and there is, you know, in one of the articles too, he says you need to have a firm, a solid background in one area. So he basically makes this case that you should have, like, I have a degree in a PhD in economics, and that gives me that. But I'm not sure exactly why they dismiss it. So we have this reductionist science, which has always been you learn about nature by breaking the problem down into smaller and smaller parts. And that's really, really important and very, very successful. And it's the approach we take. But I believe, and that's kind of analysis, you know, it's a reductionist analysis. I'm a huge believer that we need synthesis. We need somebody who specializes in how do all those pieces connect to each other. And for whatever reason, our universities do not focus much on that. And even like when I was doing my PhD, I read a study where the NSF said, you know, absolutely you should not try to be transdisciplinary either in your PhD or when you're going for tenure. Because first of all, there's few people qualified to review transdisciplinary work. You won't get published, you won't get advanced, you won't, you know, so everything said I should not do what I did. But I wouldn't have been happy doing something else. So, you know, so it is an issue. I don't know why people reject that. And they very much do though. And you know, like I'm in CALS, and I have to apply for grants in CALS, and they want very narrow disciplinary grants with, you know, with very narrow definition of the scientific method. And I think the scientific method's amazing, but I think it's necessary but not sufficient. You know, there's a whole bunch of problems that we can't tackle using the scientific method.
Martha and I were actually talking about this kind of subject, and it seemed like one idea that emerged from our discussion was that too many people transdisciplinarity implies a lack of depth.
Yeah.
So if you look at the level of, say, calculus or mathematical sophistication that's in some of these incredible conventional economist theories compared to this bubble drawing that you've made for us, there's a huge difference.
Yeah, although I would also say that most of the mathematical models in economics are taken straight from physics, so they just change the names.
I know.
And having, you know, and my ability in math is way better than any other ability. You know, I test higher on that, and I'm better at it, and it's really easy. And I just don't think it's very relevant to the problems I'm interested in. Partly because if you think about it, mathematical systems are built on axiomatic assumptions, and everything is inherent to the model. You can't have a complex adaptive system modeled mathematically because everything is a logical construct built on axioms and absolute rules, so there's no potential for this type of adaptive systems or for qualitative change. So by applying the mathematical tool, you rule out the capacity for qualitative change. There's a great article on this by Joshua Farley Phd, who used to be considered one of the leading mathematical economists, and is still, and mathematical economists hold him in awe, but he's also the father of ecological economics, but he's completely rejected all of that, said math is the wrong tool for the problems we're focused on. And, yeah. Did you have
I was going to say the another reason why transdisciplinarity is criticized is because it includes these other disciplines that are more normative and more subjective, and so it doesn't take this reductionist positivist approach to doing, using the scientific method, and it's all, neat and replicable and can tell you something about something. And I mean, the other approaches can also, but I think that's the reason why they're coming from this particular way of doing science.
And the interesting thing though in economics, very, very few of these, mathematical models. So if it's just theoretical, they're replicable often. Actually, one of my friends and I in grad school, we went through all these mathematical models and found almost every one had an error in it. So they're not even replicable, even the theoretical ones. The chair of my department went through the journal Econometrica and found using the same data and the same methods, 75% of the articles were not replicable. And if you look at conventional or contingent valuation studies, one of the leading tools used by people who call themselves ecological economists, they're almost never replicable. And in fact, they shouldn't be replicable because markets are dynamic systems, the prices change. But they, estimate a value in 1997, and they'll still use that value in their studies today, which doesn't even make any sense. I don't know, but anyway. So economics is not very replicable. And where was the one I just read about predictability? Was that one of the readings I gave you guys, or was one that I just posted? Oh, it was the one I posted, suggested that you guys read. It's just, I think I put the link to it. I forget if actually no, because you guys, this is different. I think I put the link on Blackboard maybe, but it's basically talking about how economists, model themselves after physics and have no ability to predict anything. I mean, and we have not only do we have no ability to predict anything, but we haven't improved our ability to predict anything over, the past 100 years. So there has been if predictability and replicability are your measures of success, economics is at zero success. So one of the things is transdisciplinary nature. Why is it necessary? Why do we need to take that approach? So again, this is flipping it around because you said some people criticize it, but why would we want to adopt it? And what does it encompass? Like what are the disciplines we should draw from? And why do we need to do that?
The problem dictates that we need to do that.
Yeah, so I would say the problem dictates it, and it goes to this point where, I would say we need to draw from all these things. So humanities are kind of considered like the outcast, that, that's totally not scientific. And if you look at any of the stuff, like what we need in our country, STEM, science, technology, engineering, math, this is where we should devote all our resources, this is what we need, this is what we need to solve our problems. And all this reminds me of a quote by Yogi Berra, who says, we might be lost, but we're making great time. And I would actually argue that science, technology, engineering, and math helps us make better time. But the humanities often help provide us with the direction. Philosophy, ethics, even religion, these things, where should we be going, what should our goals be? And then our first question in this class is, what are the goals? And so I don't care how fast we're going if we're going in the wrong direction. And in our society, we seem to be more obsessed with speed than going in the right direction. And so I really think that we need to build on, this question of right and wrong. And actually, I'm fairly scientific. So even when I'm looking at the questions of right and wrong, I want to look at some of the ecological or evolutionary underpinnings of that. So we'll be focusing on that in this class. But I really think we got to go across, across the discipline. And let me see what's, oh, this is a quote from Hayek, is a very famous economist, and I brought this up 237 too, but this is very relevant here. He's a really, really famous economist who's the Tea Party loves him, libertarian type. But he basically makes that warning that you need to know more than economics if you want to be a good economist. And I strongly believe, that it's dangerous if you only know economics. And it's kind of amazing how a tiny bit of economics can lead people to believe they'll be an expert in anything. And even environmental economists making the claim that they really don't need to know much about the environment because all you need to know is a few basic rules in economics and you can answer all these questions about the environment.
What was the context in which Hayek made this quote?
Do you want me to be totally honest about this? Somebody sent this, it's the little thing they put at the bottom of their email. And so I don't actually know the context. And I have not read much Hayek in his original work. I've read people writing about Hayek, but not much of his original stuff. So he's an Austrian economist, which is a field of economics. Dude, Scott, do you want?
I had a sort of question. I was just gonna say, like, in theory, shouldn't each discipline also stand on their own?
And again, it's, there's a famous quote says, in the university there's disciplines, in the real world there's problems. So should chemistry stand on its own, or should it entirely depend on what it learns from physics? Should biology stand on its own, or does it depend on what it learns from chemistry? So the question is, should each discipline stand on its own, or should each discipline recognize that it ultimately depends on the other disciplines? And this is a big issue, because I argue that the discipline should be conciliant, that a biologist should never say something that fundamentally contradicts laws of physics or laws of chemistry. And an economist should not say something that fundamentally contradicts those laws either. And that really it's knowledge is always integrated. So, but it is, it is helpful to have a sound foundation in one area.
Yeah, that's what I mean. It's like economics should be able to, model all of these things based on what's true.
Yeah, but it should recognize based on what's true, and we don't really ever know what's true, but it's based on what we. Yeah, and this is one thing I actually always think about. So we have an incredibly limited ability to perceive reality. So we can have sound waves and light waves, and in terms of the electromagnetic spectrum, if the spectrum is this, we can perceive like this, and we take those perceptions and create this vision model of reality that's wildly flawed. And then but anyway, so that's, and I have some readings on that. A good reading by Bill Reese on that. So anyway, so these are things, as I say, everything up here, everything I present is up for debate. This is a discipline, or not a discipline, it's a field in formation. I'm not telling you rigid facts. I'm telling you, so even a lot of things I put down as assumptions, and but everything is up for discussion, open for debate, and you should be trying to prove a lot of things wrong. And if you can prove them wrong, then we got to build something better. So I think now we get to the course, the stuff I was going to start with,